When it says factor completely, you always start with greatest common factor. So these three terms just have an x in common. When we take that x out, we're left with x squared minus 4x minus 5. So now we need to figure out how to factor x squared minus 4x minus 5. Because that's a trinomial with a 1 in front of the x squared, we're looking for two numbers that multiply to give us negative 5. Those same numbers have to add up to negative 4. Remember, you're always multiplying to get the third number and adding to get the middle number. The only way to multiply to get 5 is 1 times 5. Can we make 1 and 5 turn into negative 4? Negative 1 and 5. So that part factors into x minus 1, x plus 5.
Yeah, you gotta flip it around. Sit there. You guys flip it.
No. Oh, yeah. My class is right. Once again. Definitely positive 1, negative 5. Yeah, that works. So x plus 1, x minus 5. You know, start off the new year with errors in my video. It's cool. It's cool. Don't forget, you've got an x in front of all of that. So get that x in front, and then your polynomial is fully factored. Let's take a look at B. For starters, greatest common factor. What do 3y to the 5th and 48y to the 3rd have in common? Start with the numbers 3 and 48. Can we divide 48 by 3? Probably. So 3. Then y to the 5th means there are 5 factors of y. Y to the 3rd means there are 3 factors of y. So how many factors of y could they both give up? 3. Hint, you're always looking for the smallest exponent. That will tell you how many of the letters you need to factor out. Okay. 3 divided by 3 is 1, but we don't really need to write that 1. Y to the 5th divided by y to the 3rd is y squared. You've got 5 y's. You're taking 3 of them out. That leaves 2 of them left over. Negative 48 divided by 3 is negative 16. And we're taking y to the 3rd out. All right, is this one done? Is it fully factored? No, y squared minus 16, that is a difference of 2 squares. Y squared is the perfect square of y. 16 is the perfect square of 4. So that part factors into y plus 4, y minus 4. Don't forget the 3y to the 3rd in front.
Oh, that's the answer?
Mm-hmm. Okay, I would like you to try C on your own. Okay, first I always start with the numbers. 5, 30, and 45. We can divide all of those by 5. And then the smallest z is z squared, so we can pull z squared out of all of them. And then we factor what's left. You should end up with 5z squared times z plus 3 times z plus 3. Do you notice anything interesting about the z plus 3 and the z plus 3? They are completely identical. That means we can write it as z plus 3 squared with the 5z squared in front. Now I want you to see the difference between B and C. In example C, z plus 3 was identical to z plus 3, so we can write it as z plus 3 squared. In example B, are those two parentheses identical? Okay, so you might want to make yourself a note. These are not identical, so you cannot collapse it down into one set of parentheses. You have to leave them separate. On the back of that page, let's look at sum and difference of 2 cubes. This is kind of like the difference of 2 squares. If we have something like x squared minus 16, we know that that factors into x plus 4, x minus 4. We have a similar pattern when we have the sum or the difference of 2 cubes. And I will always give you these formulas, but honestly, these formulas are not very difficult to memorize. So I'm going to show you how to use these formulas in a way that may actually help you get them memorized. So at the top of the page, there's a list of perfect cubes for 1 through 10. So 1 cubed is 1, 2 cubed is 8, 7 cubed is 343. You can also use this backwards. So if I ask you, what is 729 the perfect cube of? It's the perfect cube of 9. All right, for the sum of 2 cubes, you got something cubed plus something cubed. So here's x cubed plus 216. We need to figure out x cubed is the perfect cube of x, and 216 is the perfect cube of 6. So in this formula that you're given, A is going to be our x, B is 6. Anywhere you see A, you're going to put x. Anywhere you see B, you're going to put 6. So the pattern says A, so x, and then B, so 6. Then inside the second set of parentheses, it says A squared, so x squared, and I put that square in that blank for you. In the middle one, it says multiply the two together. So x times 6, and then b squared, so 6 squared. Now let's look at what this creates. This makes x plus 6, x squared, minus 6x, plus 36. Does everyone see where the 36 came from? 6 squared is 36. Okay, do that same thing for the difference of 2 cubes. Notice it's still 216. So your A is going to be x, your B is still going to be 6. Fill in those blanks and then write the simplified what that would turn into. So try that second one on your own. Did you notice that these are basically identical? What is not identical? The signs. Let's look at those signs. The first sign matches what you originally started with. So when we started with plus, that first sign is plus. When we started with minus, the first sign is minus. The next sign is the opposite of whatever we started with. So when we start with plus, the second sign is minus. When we start with minus, the second sign is plus. Notice the last one is always plus. So same, opposite, plus. As far as what you put in the blanks, it's first thing, second thing, first thing squared, multiply them together, second thing squared. So I basically have AB, A squared, AB, B squared. I have that memorized in my head, and by the time you've used this a few times, you'll start to memorize that, and then you just have to figure out the signs. So when we actually start using the sum and difference of 2 cubes, I'm going to write this. A, B, A squared, AB, B squared, and leave the signs out. If you wanted to, you could write in that this sign will be the same, this sign will be the opposite, and that sign will always be plus. So that basically is what I have memorized in my head, and that allows me to use this pattern correctly without having to look back and follow the formula. Okay, let's use this for x cubed minus 125. First, we have to figure out x cubed is the perfect cube of what? X. 125 is the perfect cube of what? So look up at the top of the page. 125 is the perfect cube of 5. Okay, now I will be honest, there's not a ton of space here. So we have x 5. So first thing, second thing. In the next set of parentheses, first thing squared. In the middle spot, you multiply them together. What is x times 5? 5x. And then the last space is the second thing squared. What is 5 squared? 25. Now we need to do the signs. We started with minus. So our first sign is minus. The next sign is the opposite of that. And the last sign is always plus. Now, if any of you are thinking, all right, you said something about factor completely. Do we have to factor x squared plus 5x plus 25? You could try. It won't factor. It won't. So if you look at all the ways to multiply to get 25, none of them will add up to 5. So you're good. You're done. That is the fully factored form. So when you factor x cubed minus 125, you get x minus 5 times x squared plus 5x plus 25. All right, let's try the next one. First of all, a cubed is the perfect cube of a. What is 27 the perfect cube of? 3. So everywhere that you see a, you're going to use a. How helpful. Everywhere you see b, you're going to use 3. So we've got a 3. Anyone feel brave and want to try filling in the second set of parentheses for me? A squared.
27a.
Close.
Minus 27a.
3a. 3 squared. 9. Okay. And I always do the terms first, and then I go back to do the symbols. So we started with plus, so we got plus, minus, always plus. I want you to try C on your own. If you're watching the video, pause the video. Pause it, pause it, pause it. Okay, in example E, there's something in front of the x cubed. Now I noticed that 27 is on our chart at the top of the page. 27 is the perfect cube of 3. Is 64 on the chart? 64 is the perfect cube of 4. So this time, instead of our a just being x, this time our a is 4x. So let's see how that affects things. We've got first thing 4x, second thing 3. In this spot, we are supposed to do the first thing squared. What does squaring something really mean? You multiply it times itself. So we really need to do 4x squared, which means 4x times 4x. What is 4x times 4x? 16x squared. This term is the most commonly missed thing when you're factoring this particular polynomial. A lot of people just write 4x squared and call it good, but you have to square 4x. You have to take 4x times itself. In the middle, we're supposed to multiply the two things together. So 4x times 3, that would be 12x. And then this last thing is supposed to be 3 squared. That one's still pretty easy. That's 9. We started with plus, so our symbols are going to go plus, minus, plus. Okay, so some of you are thinking, all right, not a big deal, totally fine. You move to example F, well, hold on a minute, 16 and 54 aren't on that list. The other thing is, do you notice that it's not s to the third, it's s to the fifth? So these two terms have something in common. We first need to do GCF and figure out what they have in common. Look at what these two terms have in common. They have 2s squared in common. Pull that out, and now we need to factor 8s cubed plus 27. All right, your assignment is in the book on page 184. I do have a PDF of that on my website, and the problem numbers are 5 through 8 and 13 through 16.
only one that'll be in the book.